In this video, we will discuss how to solve for a limiting reactant and how to figure out how much of your excess reactant is actually left over in a reaction. And this set of notes is kind of the bulk of stoichiometry, and you'll see a lot of questions on your test, I'm sure, dealing with limiting reactant problems. But this video will show you by far the easiest way to figure out limiting reactants. So a limiting reactant is what reactant runs out first. And so maybe you have a reaction A plus B goes to C plus D, and if A runs out, the reaction stops. Okay, and so A would be considered my limiting reactant. Sometimes you can set it up, and this is oftentimes what happens if you if your job is in industry where you do chemical reactions. It's not very helpful to have leftover things. So in this reaction, B would be left over. So it is possible, and we'll see that you can make both of them limiting so they run out at exactly the same time. So here are the steps. The first step, like most chemistry problems, will be get moles. Divide by the coefficient, and whatever number is the smallest, that's your limiting reactant, and that's it. And then the key step, and this is what a lot of people forget sometimes, is that whatever is your limiting reactant, you're going to use that for any conversions. It doesn't matter what the conversion is, you are going to use that limiting reactant going forward. So let's look at this example problem, and we'll see how this works. We are given 5.2 liters of nitrogen and 4.09 moles of hydrogen. They react to form ammonia, which is in window cleaner, and we want to know how many grams of that ammonia, that product, will be formed at STP. So the very first thing we need to do is we got to have a reaction. Okay, it's very hard to do anything in chemistry without the reaction. So we're going to take nitrogen. It's going to react in a synthesis reaction to produce it's going to react with hydrogen to produce NH3, and we need to have this balanced. So I already have it balanced. And step one for figuring out the limiting reactant is get moles. Okay, basically what this problem is saying is I have a random amount of nitrogen and a random amount of hydrogen. One of them will run out at some point, and that'll stop your reaction. Which one will run out first, and then use that amount to figure out how much NH3 is actually going to be made. So we need to get moles of nitrogen, and we need to get moles of hydrogen. Luckily, they give us 4.09 moles of hydrogen, and we need to get moles of nitrogen. We are given 5.12 liters of nitrogen at STP. And I can always get to moles in one step, and that's kind of nice. I'm going to go from liters of nitrogen at STP to moles of nitrogen at STP. And since this is not a mole bridge conversion, I know it's going to be 1 mole, and that's going to be 22.4 liters. So when I math that out, I get 0.229 moles of nitrogen. And right now, I have less nitrogen compared to hydrogen, but that doesn't tell me that nitrogen is going to run out first. I mean, nitrogen may run out first, but what I need to do is I have to compare it to the situation that both of these are going in, which is the reaction. And so my next step is going to be I'm going to divide by the coefficient. The coefficient of nitrogen is 1. So what I end up getting is I get 0.229. And then I'm going to divide hydrogen by 3, and I get 1.36. And so because nitrogen's number, this red number, is less, I know that nitrogen is my limiting reactant. And as soon as you identify a limiting reactant, you need to write it down because you don't want to forget that. And then hydrogen is going to be left over, and H2 is excess. Okay, so now I figured out the limiting reactant. It was just that easy. Now I want to actually answer this question: how many grams of the ammonia will be produced? And so what I'm going to do is I'm going to use my limiting, which is nitrogen. Now here's a really good question. And the question is, should I use these blue moles, the 0.229, or the red one, 0.229? They're the same numbers, so the math is going to be the same, to actually convert this. And the answer is use your actual moles, which are your blue ones here, 0.229 moles of N2. Because as we see, this number is 1, the coefficient, and so that made the math give me the same number. You have balanced plenty of reactions by now, so hopefully you understand that that coefficient is 1 sometimes, but not always, and so whatever number we get over here in red could be different, okay? And so that's why we need to make sure we use our actual moles. These are the actual moles that we had in the reaction. And I'm just going to convert that to grams of NH3, so I'm going to say, okay, I'm already at moles, so that means I'm at the mole bridge. I'm going to go from moles of N2 to moles of NH3. Looking at my reaction, there is 1 mole of N2 for every 2 moles of NH3. And then I need to get to grams, and in 1 mole of NH3, there's 17.04 grams of NH3. And so I can math this out, and I get 7.80 grams of NH3. Okay, let's look at another example. Here we have aluminum sulfide. That's going to be Al plus 3 S2 minus, so I'm going to get Al2 S3. And aluminum sulfide is going to react with hydrogen phosphate, H plus 1, PO4, 3 minus, so H3PO4. And that's going to produce, it doesn't tell me, but I know that this is going to be a double replacement reaction. So I'm going to get hydrogen is going to react and be with sulfide, so I get H2S, plus I know aluminum and phosphate are going to bond together, so I'm going to get AlPO4, and then to get this balance, that would be 2, 3, and then 2. And here's what I want to know, is I want to know how many grams of hydrogen sulfide, that would be this guy, can be produced if I start with 45.9 grams of aluminum sulfide and 94 grams of hydrogen phosphate. And so basically one of these numbers I'll just convert to hydrogen sulfide. The problem is I don't know which number to choose, and I can only start with 1. And so what I know now, because of that, because I don't know which one to choose, this is a limiting reactant problem. And so I have 2 steps for a limiting reactant problem. Step 1 is get moles. And then step 2 will be just divide by their coefficients. So I'm going to take Al2S3 and I'm going to get moles for that one. And then I'm going to get H3PO4 and I'm going to get moles for that one. And I'm given 45.9 grams of aluminum sulfide. Using my periodic table, I can do the math here really quickly, and there's 150.14 grams of Al2S3 for every 1 mole of Al2S3, and that ends up being 0.306 moles of Al2S3. And then to get moles of H3PO4, I'm going to take 94.0 grams of H3PO4. To get the molar mass of H3PO4, I'm just going to use my periodic table, and the mass for hydrogen that I'm using is 1.01, and so there's 98.00 grams of H3PO4 for every 1 mole of H3PO4. And when I math that out, I get 0.959 moles of H3PO4. What I need to do is step 2, and step 2 would be divide by coefficient. So what I can do is I can move my moles and I can copy those down here. Oops. And I can divide them by their coefficients. Aluminum sulfide will be divided by 1. Hydrogen phosphate will be divided by 2. And what I end up with is 0.306 and 0.4795. And so because aluminum sulfide is less, I know Al2S3 is going to run out first, and that is called my limiting reactant. And then H3PO4 is actually going to be my excess reactant, so I'll still have some of that left over. And so what I'm going to do is I'm going to make this just a little bit smaller to give me some room. And I need to answer the question. I've done these 2 steps, but I haven't answered the question. And the question is, how many grams of hydrogen sulfide are actually produced? Well, because aluminum sulfide is my limiting reactant, I'm going to use that for any conversions that they ask. Whatever the problem may ask, I always use my limiting reactant. But I'm given 0.306 moles of Al2S3 and 0.306 in red, and so I've got to remember the actual moles are what I use, because the only reason 0.306 in red was is because the coefficient of aluminum sulfide is 1. So I want to always make sure I use my actual moles. So I'm going to take 0.306 moles of Al2S3, and I'm going to convert that to hydrogen sulfide. So I'm going to go from here all the way over here. And because I already have moles, I'm already at the mole bridge step. I'm going to go from moles of Al2S3 to moles of H2S, and looking up here, that ratio is 1 to 2 based on the coefficients. But the problem asks for grams, so I'm just going to go one step further and say in 1 mole of H2S, there are 34.08 grams of H2S, and so that'll give me 31.3 grams of H2S. And so I answer the question. This next question is kind of a hard one, and it's the same reaction, but it says, how many grams of leftover reactant are there? Well, we've already decided that H3PO4 is excess, so that means that it's left over. So this is saying how many grams of H3PO4 are actually left over. And so here's how I'm going to do this one. This is going to be a conversion, and we're going to start all of our conversions with our limiting reactant. So 0.306 grams, or excuse me, this is moles of Al2S3. I'm just going to convert that to H3PO4. So since I'm starting with moles, I'm already at the mole bridge. Scrolling up, going from aluminum sulfide to hydrogen phosphate. There's 1 mole of aluminum sulfide for every 2 moles of H3PO4. And then they ask for grams, so I'm going to say in 1 mole of H3PO4, there is 98.00 grams of H3PO4. And when I map this out, I get 59.976 grams of H3PO4. But the problem is what I've just converted was how much aluminum sulfide I used to how much H3PO4 I used. Okay, because there's no more leftover aluminum sulfide because it's limiting. So what I want to do is if I am ever asked about leftover, I'm going to make sure all my units say used. Because when I finish my fence, oftentimes that's the end of the problem, but here it's not. This is how much H3PO4 was used. And so if I go and I scroll up, I started with 94 grams of H3PO4. I am using 59.976 grams of H3PO4. My sig figs are probably off a little bit, but that's okay. And when I subtract the two, I find out that there's 34.024 grams of H3PO4 left over. Okay, and so that's my final answer. I'm going to do one more example problem, and I know that'll make this video a little bit longer than what I would like, but this is just so important for the rest of the year in chemistry, and if you continue on that, just want to make sure there's another example for you to look at if you need it. And what we have is we have bromine, and it's reacting with lithium iodide. Remember, bromine is a diatomic element, part of your Brinkelhoff elements. So it's Br2, it's reacting with lithium iodide. And this is going to be a single replacement reaction where halogens actually replace halogens. And so what we get is we get LiBr plus I2. And to get this balanced, I'll put a 2 there and a 2 there, and it looks good. We are asked how many grams of iodine, which is right over here, will be produced if we start out with these random amounts of 5.13 grams of lithium iodide and 1.441 grams of bromine. So basically, I just need to take one of these numbers and convert it to iodine. The problem is I don't know which one to choose. And so when that happens, that's going to be a limiting reactant problem. And step 1 is get moles. Okay, so we'll have lithium iodide. We'll take 5.13 grams of Li, and we will convert that using the molar mass. And when I solve that out, I get 0.0383 moles of Lii. And then I'll do the same thing for bromine. And I started out with 1.441 grams of Br2. There are 159.80 grams of Br2 for every 1 mole of Br. Don't forget that since this is bromine, the molar mass is 79.90 for just 1 Br, but since this is Br2, we have to have that doubled. Okay, and when I math that out, I get 0.00902 moles of Br2. And then step 2 is divide by coefficient. And what I'm going to do is I'm going to just copy and paste these guys. Copy. Okay, and so I'll divide Lii by 2. Bromine, it looks like I'll divide it by 1. And then what I end up getting is I get 0.01915 and 0.00902. And so since the bromine 1 is less, I know Br2 is limiting. And then Lii is excess. And so now that I have identified my limiting reactant, I use my limiting reactant every single time in any sort of conversion. So I'm going to convert it to grams of iodine. I have 2 numbers, they're the same, but of course I use my blue one because that is my actual moles. The only reason the red one is the same number is because the coefficient of Br2 was 1. So I'm going to take 0.00902 moles of Br2, and I'm just going to convert that to iodine. Since I'm starting with moles, I'm already at the mole bridge, and so I'm going to go from moles of Br2 to moles of I2, and I'm going to find that ratio. There's 1 there and 1 there, so that's actually a 1-to-1 ratio. And then the problem asks for grams, so I just have to do one last step. And I have to say in 1 mole of I2, there is 253.82 grams of I2. So when I map that out, I get 2.29 grams of I2. And that is my answer for part B. And then C, this is probably the hardest question of the whole unit, is how many grams of leftover reactant are there? Well, lithium iodide was my excess, so this is saying grams of LiI. And whenever I need to convert to something, I always start with my limiting reactant. And so I'm going to say 0.00902 moles of Br2, that's my limiting, and I'm just going to convert it to LiI. And since I'm asking about leftover, I know I want to say used. And we'll see why at the end of this. Since I'm already at moles, that means I'm at the mole bridge, so I'll go from moles of Br2 to moles of LiI. Looking at that ratio, that is a 1 to 2 ratio. And these are used. And then in 1 mole of LiI used, there's going to be 133.85 grams of LiI used. And when I math that out, I get 2.41 grams of lithium iodide that I used. The question asks for leftover, so I just have to look back up. And it looks like I started with 5.13 grams of LiI. I just calculated that I started with 2.41 grams of LiI. So when I math that out, there's 2.72 grams of LiI that is left over. And what would that look like? It's just going to be sitting in my beaker.